Yeah, so I don't know. I'm just gonna record the session so you guys can revisit it afterwards. But anyway, let's continue. So the next question they ask you for the coefficient of kinetic friction. So what you must look at now is kinetic friction on the horizontal, on the horizontal or on the vertical plane the of of the motion of the box. So we know that kinetic friction is gonna be on the horizontal plane. So here we're gonna have our Fk, and here I wrote the equation for kinetic friction. So from the previous question, we calculated our normal force, which is 372.06 newtons upward, or you can write positive or whatever you prefer to indicate the direction. And now we have our normal. They want us to find the coefficient. This is the one they want us to find. But we also don't have our kinetic friction. So our normal is here. Sorry. Our normal is here. We don't have the coefficient and we don't have the kinetic friction. So in order to find the kinetic friction, we look at our keyword, which is this box moves at a constant velocity. And as we know that when something is moving at a constant velocity, the acceleration is 0. That means our net force is gonna be 0. And since there's only like two forces acting on acting on the box, this is gonna be FAX. So as you can see, there's two forces acting on the box. This is opposing this one, and that causes the box to move at a constant velocity. And we did calculate the horizontal component of FA here. It's 58.85. So we're just gonna substitute that in 57.85 minus FK. And we're gonna end up getting FK is equal to 57.85 newtons. And if you wanna indicate the direction, you can say negative, since you can see that the kinetic friction is acting to the left, or you can just state in your statement, you can just state here that Fk is equal to 57.85 to the left. But since this is not your final answer, you don't have to say that it's not important to say it. But if you want to state it just for your own clarity, you can state it, but it's not crucial to what we're doing. currently. So now all we have to do is rearrange this equation. We're going to divide both sides by the normal force. Let me just swap some of this stuff out. Yeah. So we're going to rearrange this, divide both sides by the normal force, divide this by the normal force. Then we're going to end up with our mu k is equal to uh, here we're gonna have our 57.85, and below we're gonna have 372.06. Jason, what's your answer for the coefficient? Sorry? Can you hear me? Because I asked you a question.
Yes, I can hear you.
Yeah, I'm just asking like what's your answer for this?
So I got 0,156, sorry, 0,16.
So when you were doing it by yourself, did you get the same answer or was it different?
So I just figured that the normal force has to be the opposite, because I figured if you calculated the 50 degrees already, then we just need to calculate the 40. So then I did 40 sine 40 degrees.
Oh, okay. But actually, I I'll explain most of this stuff to you when we meet because I can see that you are close to understanding the concept. You just need a bit of a push. But to be honest, this is basically vectors in 2D. It's just that now we're gonna start applying laws to them. So if you don't know your grade 10 trigonometry, it's gonna be a bit difficult to do this. So if you go look at your trigonometry from like grade 10 and grade 9, just like the introduction to trigonometry, it's gonna become easier for you to do these because it's basically just vectors into the just in a different way. So they say, will the coefficient of kinetic friction change if the angle of the force applied is decreased? Write only yes and no and give your answer. What do you guys think? Is the coefficient gonna decrease or increase? Will it change at all actually?
You
If
said
this
it won't change. It
if this
won't change. It
angle
won't
is
decrease
changed,
if changed, because the angle would be smaller, and so the total amount that you get will also decrease, which will decrease the applied force.
what do you think is gonna, let's say you're gonna decrease the applied force. Before you can relate the applied force to the coefficient, you have to relate it to the friction. So if you change the applied force, right, isn't the friction also gonna change?
Yes, sir. It's gonna be less.
And since we know that friction and applied force are equal, but just acting in different directions, do you think the coefficient of friction is gonna change?
No, sir, it's not gonna change.
Okay, thank you. Actually, it won't change because I don't like the problem is that I can't find the right ways to articulate or the reason. But if the angle of the applied force changes and there's less force being applied, that's gonna that's gonna affect the normal force. It's also gonna change. The normal force is gonna become bigger. um yeah, it is gonna become bigger since this is not gonna go up or go down. Then if the normal force becomes bigger, we're gonna change the force applied. The force applied is gonna become smaller. Here there's gonna be a smaller number but a bigger number below. So usually it's not gonna change because for the for the for the coefficient of kinetic friction to change, you have to change the surface at which the object is moving on. So the coefficient is independent of the forces. It's dependent on the surface that the object is moving on. So I think that's a better reason. The answer is no. And the reason is that the coefficient of kinetic friction depends on the surface that the object is moving on and is independent of the forces or does not depend on the forces. But you can just say it depends on the surface and leave it like that. So do you understand that?
Yes, sir.
Okay. So Kyle, are you with us or
I understand, sir. I'm with you.
okay, so did you see how we calculated for 3.5 or should just like quickly go explain that and then come back?
Oh no, sir, it's fine. I understand it.
Oh, okay. Thanks. So yeah, I don't think we should be here for any longer. So for the rest of the time, if you have questions, you can ask them. It doesn't have to be related to this. It can be related to anything else. You can just ask me those questions. But if you don't, then I think we can end the meeting and you can just enjoy your day. So you have questions?
No, sir.
Okay. Kyle, Zach, if you can't speak, you can just write them in the chat. Okay, so Zach doesn't have any questions. Jason, are you fine?
Yes, sir. No questions.
Oh, okay, so that's fine. Um, Jason will do that question on Monday.
Yes, sir.
I'll just tell me when you're free, and we'll just chat about it privately, and then we'll see what happens. And then yeah, then have a good day. Enjoy your weekend.
Yes, sir. Bye.
Bye.
Bye, sir.